Hi, my name is Adam. Welcome back to GodotGameLab. In this video, we're taking a little bit of a breather because we did some heavy lifting in the last two videos. So in this one, we'll explore Godot's resource system in a lot more detail. You can see that we already have a player character, and this crab enemy has a health component attached to it. So we'll see how we can use our resources with the nodes we have. And if I left click with the mouse button, you can see that the crab enemy has lost a portion of its health and gained some block after that. And if I right click, the same happens to the player character, loses some health, gains some block. And the StatsUI gets updated accordingly by relying on the resource for the data itself. So without further ado, let's get started. First of all, I promised a more in-depth look of resources in Godot, so why don't we start with that? We already created a theme for the project, right? That's a resource. So what's the advantage of using a resource for this? Well, the biggest one is that we only need to define the design specifics once and share that data between different nodes and scenes. So if we design how our buttons look like, what font we use for the project and so on, we can share these details between all the different screens and menus we have in the game. So for example, the main menu, the level up screen, the save load window, the options menu, the credits, the game over screen, you get the idea. And then if the designer comes in and says, okay, this button should be changed, we only need to change it in the theme itself and all the screens will update accordingly. Resources are basically data containers, meaning their primary goal is to store and contain some sort of data. In the case of the themes, if you think about it, it's all the design specifics, the font size, the font type, how buttons look like, what kind of style boxes they use, and so on. We usually don't use resources by themselves. We want the nodes to use the data which is contained in the resource files, right? And another big advantage is resources are only loaded once. In Godot, if you try to load the resource again when it was already loaded, then you will just get the reference to that already loaded resource, preventing you from loading it over and over again, creating a performance bottleneck. And the last one, which is a big one, is that they can be nested. So a resource can contain another resource in its own data container. I took all these from the Godot documentation, so if you want to read more about the resources, you can check the link. Just to show you another example, in our game, we'll define the CharacterStats as a resource, and we'll reuse it in a bunch of different places, like the battle node, in the battle UI node to display the current mana, for example, or in the player node to display the stats, the health and the block, and so on. So with this solution, these nodes don't really need to communicate with each other to get these data, because they can just access it from directly the resource itself. Cool, right? So open up the project, and we can start creating a bunch of new custom resources. In the file system doc, let's select the custom resources folder, right-click, create new script. Let's start with the CardPile, and make sure that it inherits not from the node class, but from the resource class. Press create, double click and open this up. Okay, so the first thing we do is we define a class name for the CardPile, so we can use it as a static type throughout the project. Then we'll define a signal when the CardPile size has changed, and we'll pass in a parameter for the amount of cards we'll have after the change. And then for the data structure, it's pretty simple actually. The only thing we need to have is an array of cards. But we'll define a bunch of utility functions because if you remember, we can also create functions inside of resources. So we'll define a function to check if the card pile is empty or not, which is just returning whether the array is empty or not. Then we'll have a function for drawing a single card, which will pop the front value from the array, then emit the card pile size changed signal, and return the card we popped from the array. Here you could argue that popping the front value from an array is much more resource heavy or performance heavy than popping the back value. But I think for this project, worrying about something like this would be premature optimization, right? Because when you think about Slay the Spire, how big your deck can get when you end your run. It's like 30 to 40 cards maximum, I think. And with an array of 30 or 40, that's not a problem. That's not a performance bottleneck. So you don't need to worry about this. If the game gets a performance hit because of this function, because we use the pop front instead of the pop back, we can always refactor, right? So we don't need to prematurely optimize for this, I think. Okay, next up, we'll have a function to add a new card, which means appending the card to our array and emitting the card pile size changed signal. We'll have a method to shuffle our deck, which is really just calling the shuffle function for the array. We also have a function to clear the card pile, which means clearing the array and again emitting the signal that the card pile size has been changed. And finally, I override the toString function. So if we ever want to print out a card pile for debugging purposes, we'll just use a pacstring array for the strings and iterate through all the cards and append the string to the array with the position of the card and the card's ID, and join those strings or array of strings together with a new line character and return that string from the function. Go ahead and save this script, and that's all we really need for the CardPile resource. But now if we go back to the file system, we can create a CardPile, namely the warrior characters starting deck. So let's expand the characters folder. We can collapse the cards under the warrior, select the warriors folder, right click, create new resource, and search for CardPile. And again, because we defined a custom class name, we should see this resource available from this list. Press create, and let's call this warrior underscore starting deck. Save this, double click to edit it in the inspector, and you can see that we only have one property for the cards, which is fine because we only defined one export variable. So if we click on this array, we can say that, let's say we have 10 cards in our starting deck, and this will all be empty. And if we expand the cards folder again, we can drag the warrior X attack and the warrior block cards. And to fill up the empty spaces, we could do something like dragging it again. But the way I usually do this is just to drag it from here. So we have 5 attacks and 5 block cards as the starting deck. So that's all for the CardPiles for now. And let's move on to the next one. The next one we'll create is the stats. So again, let's select the custom resources folder, right click, create new script, call this stats.gd, and again, inherit not from the node class, but rather the resource class. Press create and double click this stats.gd to open it up. So the stats script is a really important one because we'll use this resource to keep track of the health and the block for both the enemies and the player characters too. So let's start by defining a custom class name, stats, so we can use this as a static type throughout the whole project. Then we'll have a signal when the stats changed. We'll use this signal to notify, for example, the UI to change how much health or block an enemy or the player currently has. Then we'll have 2 export variables, one for the maximum health and one for the image, the texture of this enemy or player character. And we'll have 2 member variables, health and block, and they use their own custom setter functions, so we can emit the stats change signal. So for the health, when we set it to a new value, we do 2 things. First of all, we clamp the value, the new value, between 0 and maximum health. Why? Because we don't want the health to go over the maximum health we can have, and we don't want it to go under 0 either, because we don't want to have negative health, right? And then after changing it to this clamped value, we emit the stats change signal. And for the block, we'll do something really similar. The only difference is that we clamp the value between 0 and 999, because that's the maximum block you can have in Spire, so I figured I'd go with this too. Then we'll have a function to take damage, which is a bit more of a complicated one. So first of all, if the damage is less than or equal to 0, we can return from the function because we don't need to do anything. Otherwise, we store the initial damage value in a separate variable, and then we calculate the real damage we take. And to do this, we'll subtract the block from the damage number and clamp that value between 0 and damage. Because if we have more block than the damage we would take, that would mean taking negative damage, which doesn't really make sense. We need to clamp this value between 0 and damage. And then we update both our health and the current block we have. We use self.block and self.health here to make sure that the setter function gets called. So for the block, to calculate how much block we'll have remaining, we need to subtract the initial damage from our current block. And again, we can clamp this value between 0 and block to make sure that we don't go under 0 into the negatives. And for the health, we just subtract the real damage we calculated from our current health. I hope that makes sense. We'll have a function for healing, which is pretty simple. We'll just update the health with the amount we want to heal. And we'll also have a create instance function, which returns a new stats resource. So what we do is we duplicate this resource we have and initialize it by setting the health to our max health and setting the block to 0 and return this new resource instance. So why do we need this function at all? Well, the reason behind this, if you think about it, you can have multiple enemies from the same kind. So let's say we did this crab enemy in the scene. So let's say you have to fight 3 crab enemies, right? And if you remember, I said that resources are loaded once. So all 3 crab enemies would share the same resource we defined in the enemies folder for the crab enemy stats. And if they have 10 health, for example, and they share the same one resource we defined in the project folder, then that would mean if one of the crabs takes 3 damage, all of the crabs' health would be set to 7 from 10, for example, because they share the same resource and it is only loaded once. We want to avoid that, right? Because we want to track the stats individually for all the crab enemies. But to do that, we need to duplicate the resource. And we do this from code, so you wouldn't have to do it in the file system. Because if you remember, we create resources in the file system, right? And okay, if I want to have 10 gremlin enemies, I don't want to create 10 identical resources just so we can track their health individually. It's much easier to do this from code because we'll just provide a function like this and we'll call this function in the enemies script to create a duplicate of the source data, so to speak. I hope this makes sense. Let me know in the comments if I need to explain this in more detail, okay? But for now, we're done with the stat script, so save this with Ctrl S. And so to test out the stats and create a new resource, let's go back to the file system doc. For now, we can collapse the folders so we can see our structure better and create a new folder under the root folder. So let's select the root folder, create new folder, and we'll call these enemies. Under the enemies, create again a new folder. Let's call this the crab enemy. And if we expand this, we'll have this crab. And here we can create a new resource. Search for stats.gd. Create a new one. And for now, we can call this test enemy. Save this. And double click to open it up in the inspector. And you can see that we have the 2 values we wanted. We have the max health. Let's set it to something like 10. And the art, which is a texture. So we can go to load art and use this crab enemy sprite. So we'll have an example stats resource we can use to test out the UI later. That's it for the stats. And the last resource we'll do in this video is the CharacterStats, which extends this basic stats functionality we have here. So again, go to the custom resources folder, right click, create new script, call this CharacterStats.gd, and this one will inherit neither from the node and neither from the resource class, but rather the stats class we already have. And double click the script to open it up. So what do we need to do in the CharacterStats resource? Well, first of all, let's not forget that we have access to all the stuff we provided in the stats resource. So the health, the block, the taking damage function, all of that good stuff we already have access to, and we'll build on top of that. So first of all, let's define a class name, and let's call this CharacterStats. Then we'll have 3 export variables. One for the starting deck, which is a CardPile. If you remember, we already created that resource, by the way. And we'll have a number to determine how many cards we can draw in a turn. And we'll also have a variable for the maximum mana this character has. And then we'll have member variables, one for the current mana we have. We'll also define a setter function for this, just like we did for the block and the health. And we have 3 more CardPiles actually. One for the current deck the player has, one for the discard pile, and one for the draw pile too. So the setter function for the mana is pretty simple. We set the value to the new value we passed on, and we'll emit the stats change signal so the UI can update accordingly. And one thing you could ask, hey Adam, we use this clamp function extensively to set the block and the health. Why don't we use it here? Well, because if you think about Slay the Spire, for example, the Watcher character has a card called Miracle. And if you use that card, it costs 0 and provides you for that turn an extra mana. This means that in the case of the mana, we can actually go above the maximum limit we have in our deck. Temporarily, but we can. So in this case, it doesn't really make sense to clamp the mana between the maximum mana and, let's say, 0. And you could argue that, okay, we can clamp it between 0 and 999, so we can go into the negatives. And while, yeah, you can do that, I don't think it's necessary, because in theory, you can't really go into the negatives, because if you don't have enough mana to play the card, then you can't play it. So you can't subtract from your mana that much. But again, if we find a bug for this later on in the project, we can always refactor it, right? It's just one line of code and we can clamp it between 0 and 99 or 999. For now, I just leave it as it is. So the next up is the reset mana function, which is just calling self.mana, so the setter gets called, and resetting it to the max mana. This will be called in the start of every turn. Then we'll have a simple boolean function to check if we can play a card or not. We'll pass that card as a parameter and return whether the mana is greater than or equal to the card's cost. Then we'll have a create instance function, which serves a similar purpose to the one we've seen with the base stats resource. But here we need to do a bunch of other stuff. So first of all, we duplicate the CharacterStats instance. Then we set the health to max health, the block to 0, but then we also reset the mana. We set the current deck to a duplicate of the starting deck. Why do we need this? Well, because if you think about it, the starting deck we would use at the beginning of every run. But then you start drafting new cards and new cards added to the deck, some cards getting removed from the deck, right? So we need to separate between those two. Because if you were to modify the original deck, then you would be in trouble because it's saved on the disk, and when you start the next run, you wouldn't start with the 10 cards we have, the 5 attack cards and the 5 defense cards, but you would end up with starting with your deck from the previous run. So we need to have a current deck and we need to have the starting deck as a separate card pile. And then for the draw pile and the discard pile, we start them both as empty card piles. We create a new card pile with this card pile.new, and with everything set up, we return this instance from the function. That's all the code we need for the CharacterStats resource. Now let's go ahead and create it. So go back to the file system doc and expand characters, and under the warrior, if we collapse the cards, we can put the character right next to the starting deck, I think. So right click on the warrior folder, create new, resource, and search for CharacterStats, but we have it here. And you can see it's under the stats, so you can see that it's extending that functionality. Press create, call this warrior, double click so we can edit it. And you can see that we have the properties from the CharacterStats script, but also from the stats script. So the starting deck will be the warrior starting deck. So we can drag and drop this. Cards per turn will be something like 4. Max mana will be 3. The max health, we can say something like 35. And for the art, we can load the warrior's sprite. So let's use, which one do we use? Let's use this one. Now save everything. And for this video, that's all the setup we need for the stats and the characters. We can create the UI to display those health and block numbers. To see the health and block in game, let's create the StatsUI scene next. So click on the plus sign to create a new scene. Let's go to 2D view. And this time we'll start with an HBox container node. zoom in a bit. Double click and rename this to StatsUI. So under layout and transform, we can set the size to something like 90 by 16. And we can anchor it in the center. Whichever works fine here, I use center top. And under the StatsUI, we'll create 2 new nodes. And these will be HBox containers again. So the first one will be for the block. So let's rename this to block. I can press Ctrl D to duplicate it and rename this to health. And under both of these, we'll need again 2 nodes. So let's click the plus sign again. We'll use, first of all, we use a texture rect for the icon. And if we select block again and hit plus, we'll use a label as a second one. Let's rename this to block image. And this one to block label. We can select both of these. You know what, let's set them up first. So when we copy them over, it will be less work for us to do. So for the block image, first of all, let's load the texture. And we'll use this shield icon. And you can see that it looks a bit weird. It's because the stretch mode is set to scale. So let's see. Let's use keep aspect centered. So you can see that it keeps the aspect ratio, so it looks a lot better. And for the block label, we can use a test number, something like 6. And oh, okay, what's going on with the font? It looks much bigger. Don't forget that if you select the StatsUI root node, we need to apply the theme we have. So under theme, we have this empty. Go to quick load and load the theme we have, and you can see already the font gets updated. So if we go back to the block label, we can align this to the center on both the horizontal and vertical axis. It looks like it's not centered properly because vertically it's not the same height as the icon or the container itself. So let's change that and go to layout, container sizing, and instead of shrink center, we'll use fill. So you can see it fills the whole container vertically, and now it looks a lot better. But still the image and the label are a bit far away from each other. So if we select the block HBox container and go to theme overrides and constants, we can check this separation checkbox to make sure that they have 0 separation between each other. And I think this looks fine. And actually, it's easier to just delete this health HBox container for now and select the block one and duplicate this, right? It's much faster. We can rename this to health. And we can rename both of these to health image and the other one as health label. And change this image. The texture should be whichever heart. I use heart.png. Okay, that looks fine. But you can see that here 0 separation may not be the best because the aspect ratio is different. So they are much closer to each other. So here we can go to theme overrides under the health HBox container and increase this separation. I think 2 pixels looks perfect. And maybe here we can use a different number so it doesn't look the same. Cool. Yeah, what else do we need? If you go back to the StatsUI, you can see that it's aligned to the left, which I think looks a bit weird. So maybe if we go back to the top, the inspector panel, we can set the alignment to center. And one thing we also need is we need access to both of these labels, right? Because we want to set them from the code based on the stats we have. So to do this, we could just reference the onReady variable like we usually do. But with UI, you can always change your mind about that later. Is this HBox container layout the best? What if you want to display the block and the health under each other and change it to a VBox? Then when you change the node structure for the UI, you have to update all the onReady variables. But with Godot 4, we'll have something called scene unique names. So if you right click this node and see this %sign accesses unique name, if you turn this on for the labels, then you will have this %sign here, and you can access these nodes if they have unique names for that scene. You can access them from the script no matter where they are in the scene tree, basically. And I think that's all the setup we need. So let's save this scene. Ctrl S. Go back to the root folder, go to scenes, UI, and StatsUI.tscn is fine. And let's see how we can hook up the script for it to work. So first of all, let's select the StatsUI root node and attach a new script to this. StatsUI.gd is fine. Press create and delete the auto-generated code. So what do we need in this script? Well, first of all, let's start by providing a class name for the StatsUI. And then we'll have 4 onReady variables, references to the block and the health containers, and to the labels, to both labels, the block label and the health label. And you can see that they have this %sign before their names instead of the usual $sign, meaning that they are using this scene unique names feature. Then we only need one function really, the update stats function, which receives the new stats as a parameter and updates the block labels text and the health labels text according to the block and health we have in the stats. And we also update the visibility of the block container and the health container based on the amount of block and health we have. So for example, if we have 0 block in this turn, then we don't need to display the shield and put a 0 next to it. We can just hide it, right? And that's probably the easiest way to do it. And that's all there is to it, to the StatsUI script. It doesn't need to know about anything else. It's just a self-contained UI script. So let's go ahead and save this. So in the next step, we'll hook this up with the mock enemy, and we can also create a scene for the player. We can continue by creating the player scene. So click on the plus sign to create a new scene, go back to 2D view, and for the root node, we'll use a node 2D. We can rename this to player. And originally in my reference project, I've used an area 2D for this, but looking at it now, I couldn't really justify using one because we never want to really check if we collide or target the player at all. And why don't we go with the easier solution, right? And later on, if we do need to somehow check if the mouse is over the player or not for whatever reason, we can always go back and refactor this, right? So that's not a big deal. So for now, I'll just stick to using a basic node 2D. And as a child, we'll add the sprite 2D node. And if we select the player, the root node again, we'll instantiate the StatsUI we created. So click on instantiate child scene and search for StatsUI. It's right here. So open this. And we can zoom in to see what's going on. And for the sprite 2D, let's use a placeholder image so we can see how this will look like. So select the sprite 2D, go to texture, load. And we can use the same warrior image, for example. And you can see that the StatsUI is not really at the right place because they overlap. So if we select the StatsUI, go to move mode by pressing W. And if I start to drag, I hold down shift. So I'll only move vertically. And I think something like this looks fine. So that's all right. What else do we need? For the player node, the root node, we'll also go ahead and add it to its own group. So go to the node tab, groups, and in this text box type player, for example, and add it to this group. You can see that again, this icon appears, node is in this group player. So why do we need this at all? When we'll implement card playing and card logic in the game, we need to make sure that the cards can access their targets. So we'll have one group for the player character. That's this group, the player group. And we'll have another group for all the enemies, which we'll call the enemies group. So we'll use get3.getNodesInGroup to access the valid targets when we play cards. And with that finished, we can save this scene. In the scenes folder, create a new folder. Let's call this player, and player.tscn is fine. And we need to hook up our CharacterStats resource with the StatsUI. And we'll do this from the root node, the player node. So let's attach a new script, call this player, and don't forget to delete the auto-generated code. So what do we need to do here? Well, first of all, we'll define a new class name for the player. Then we'll have an export variable for the stats, which will be of type CharacterStats. And we'll also define a setter function for this. We also have two already variables, one for the Sprite2D and one for the StatsUI. And here to get IntelliSense, we use as StatsUI after the node path. And the setter function, first of all, creates a new instance of the CharacterStats resource and assigns it to the stats export variable. And then we want to connect the stats changed signal to our updateStats function. But here I used an if check to see whether we already connected the signal or not, and only connect it if it's not connected yet. Why do we need this? Well, in Godot, the setter function for an exported variable gets called even when you run the game. So by assigning a value in the editor, calls the setter function when you run that scene. And what that means is we can accidentally connect it twice, because later on when we expand the project, we'll only assign the character stats to the battle node, which is at the very top, and we will set all the other dependencies from there. Which means that in theory, we could connect the signal twice if we already have an export variable set up for the player scene. And that can lead to unexpected behavior. But you could ask Adam, okay, why do we bother with this? Why don't we just make this a member variable and set it from the battle node where we want it to? Well, we could surely do that. And many people, I think, do this or do it this way. I think an upside for this solution, even if it looks or sounds a bit more complicated, is that we can test the scene in isolation, right? Because if we had a setup function which we use to inject the dependency, then we need someone to call that setup function in order to test the scene independently. And really with Godot, if you want to debug a project, or you want to find an error, or you just want to see how the player scene itself works, you want to be able to run it on its own, right? Not just in context. So with this solution, with a bit more overhead, I agree that it does produce a bit more overhead, we get the best of both worlds, right? Because we can still test the scene in isolation, but we can also do the stuff we wanted to do originally to get the dependency from somewhere else. And after connecting the signal, we call the update player function. And the update player function will first of all check if our stats is an instance of a character stats resource. Because if it's not, then something really messed up happened and we can return from the function immediately. But if it is a character stats resource, we need to check if we are already inside the tree or not. And if we're not, we need to await the ready signal. Why is that? Well, remember I told you that if we set the export variable in the editor, then the setter function will be called when we run the game. And from the setter function, we call this update player function too, right? And in theory, we could call this function sooner than the node is ready. And that would lead to an error, because after this, we want to set the Sprite2D's texture to the one defined in the stats resource. So we need to make sure that the node is already inside the scene tree, and then we can assign the texture. And we'll also call the update stats function, the same one which we connected to the signal. And this update stats function is pretty simple. We'll just delegate this call to the StatsUI and make sure it handles updating the health and the block. And last but not least, we'll also have a take damage function, where we'll first of all check if we are already dead or not. Because if we are already dead, we don't need to take damage. But if we're not, we'll use the stats take damage function, which we coded earlier. And also, after taking the damage, we'll check if our new health is less than or equal to 0, because if so, we can queue free the player, we can delete it from the scene. And that's all for the player code. Go ahead and save this. And we can instantiate it in the battle scene to see how it looks like. So go back to the battle scene, go back to 2D view, select the root node, the battle node, click on the instantiate child scene, and search for player. Okay, we added our new player. To keep things organized, I'll drag this, let's say, under or below the enemy. And we can move this to someplace else. Press W to enter move mode. And we can put the player, I don't know, somewhere around here looks fine. And we can also go back to the inspector tab, and you can see that the stats are empty. So we can assign our stats from the characters warrior folder, right? And if we run the scene, it should be working. And it is. So you can see that we have 35 health by default, which is perfect. That's what we have in the stats resource. Instead of the 6 block and 4 health, we have as a placeholder value in the StatsUI scene. Okay, so we're done with the player. Let's move on to the enemy next. So fortunately for us, for the enemies, we already have a bunch of stuff going on, right? Because we did some mock enemy first, earlier in the project. So we have the area 2D, which is set up correctly. We have the collision shape and the sprite. So we can reuse those. Just go ahead and right click this enemy and click Save Branch as Scene. In the scenes folder, we can create a new one and call this enemy and save it as enemy.tscn. And you can see that it collapses and we no longer have access to those children, to the child nodes. So we can go ahead and click Open in Editor to open it in a new tab, and we can edit this. So first of all, let's select the enemy, the root node, and reset its transform because we don't want every enemy to start from that position. So under transform, we can click on this reset icon. Cool. We still have the collision layers and masks set up and all that good stuff. We'll go ahead and add a new sprite 2D to this because we want to create an arrow to indicate that this is a selected target. So we can rename this to arrow. And for the texture, we can load the arrow.png from the art folder. And we can position this better. So under transform, let's rotate this by -90 degrees. And press the W to enter move mode. I'm holding down shift, so I only move in one axis. And yeah, something like this looks better. And we can also select the enemy, the root node again, and instantiate a StatsUI to this scene as well. And we can again move this down so it's not that close to the sprite. Okay, that looks fine. Go back to select mode with Q. And don't forget that we need to add the enemies to their own group as well. So select the enemy root node again, go to node, groups, and let's call these groups enemies. Press enter to add them. You can see that we successfully added it to the enemies group. Save the scene, and that's all the setup we need from the scene tree. Also, we can hide the arrow by default if it looks fine. We'll only show it when we need to. And attach a new script to the enemy. Enemy.gd is perfect. Delete the auto-generated code. So what do we need to do with the enemy? First of all, we'll define a custom class name, and then we'll have a constant for offsetting the arrow. Why do this? We already positioned the arrow in the editor, right? Well, yes, but we can assume that not all enemies will be the same width, right? So for example, if you imagine we'll have a big boss later on or something, we want the arrow to be 5 pixels to the right from the right edge of the image or the sprite of the enemy. So to do this, we need to position the arrow from code dynamically. And to do this, we can define an offset, which is how many pixels away will be the arrow from the right edge of the enemy. Then we have an export variable for the stats. Similarly to the player script, we'll use a setter function to set this. And we have 3 already variables, one for the sprite, one for the arrow, and one for the StatsUI. In the setter function, we do virtually the same thing we did with the player character. We'll create a new instance from the stats resource, assign it. Then if it's not connected to our update stats function, we'll connect the stats change signal to it, then update the enemy. The update stats function is just a delegate to the StatsUI to do this updating for us. And then in the update enemy function, really similar to the player's script, we check if the stats is a valid resource we can handle or not. If it's not, then we return. Then we need to wait for the enemy node to be inside and ready in the scene tree. And if it is, we do three things. First of all, we set the texture to the one which is defined in the resource. Then we calculate the error position, which is the right vector multiplied by half of the size of the sprite, and we offset it with the arrow offset constant. And then last but not least, we update the stats. And we also have a take damage function, which is identical to the players. If the enemy is already dead, we return. If it's not, then we take the damage by definition from the stats resource. And if after taking damage, we died, then we can queue free or delete this enemy from the scene. And that's all there is to it, to the enemy script. Let's save this. And if we go back to the battle scene, go back to 2D view, you can see that first of all, the enemy got repositioned to the top left corner because we reset its position. But that's not a problem. If we select the enemy node, go back to the inspector and press W to enter move mode, we can move it back to any position we like. I just drop him here. And we also need to assign stats to this enemy now. So if you remember, we created a temporary enemy. So let me collapse some of these folders. So if we're in the root, we go to enemies and we'll have this test enemy resource. So if I drag and drop this, we can test how the battle scene looks like. Let's play. We should see, yeah. So we see the crab enemy has 10 health and we have 35. Cool. So now, how do we test if the StatsUI gets updated or not? A pretty easy way to test this is to go to the enemies and the player script. Let's start with the enemy first. And just do something like this. In the ready callback, we'll create a timer for 2 seconds. And after the timer expires, let's say we take 6 damage and add 8 block to this enemy. And save this. And we can do something similar in the player script. So if we press Ctrl-Alt-O, search for player.gd. And in the ready callback, we'll create a timer for 2 seconds again. And we'll take 25 damage and add 17 block. But you know what, just to make sure it's working independently, let's change this to 4 seconds maybe. Save both of those scripts. And go ahead and play the game. And you can see we have the right amount. But then, first the crab enemy gets updated. And we can see the block and the health. And then our player character gets updated too. So everything's working fine. But before we wrap this up, we can get rid of this code because this was just a temporary thing to check if things are working or not. So in the player script, we can delete this ready callback. And in the enemy script, we can delete this ready callback too. Just to make sure we don't have placeholder or temporary code left. So there won't be any changes anymore. This was just a test if the StatsUI is hooked up correctly. And that's it for this video, and I'll see you in the next one. Bye bye.